Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will try and explain to you how to find out the inverse functions and how to explore if a particular function has an inverse or not. For that, one thing you must know that we have discussed earlier on, and that is that the functions are those equations or those relationships of the variables where the domain doesn't repeat itself. So if a domain repeats, it's not going to be called a function. So if you ever see a particular equation being represented on the graph like this, where you see a repetition of domain, then you will say it is not a function and domain must not repeat itself. So it's like if you're talking about speed of a car and at different times, you will say that it is never possible that at one particular time you have two possible speeds of the car. So that's the basic criteria of identifying a function. A function must not have two different values of ranges for same value of domain. Now, the process of finding out the inverse function is basically just the interchanging of domain and range. So you put domain in place of range and you put range in place of domain. Once you're doing that to find out the function, now this is basically something that's helpful where you directly want to give an input of a range and get yourself that corresponding domain. But when you're trying to interchange these variables, although you've already identified that this is an example of a function, range is allowed to repeat itself. So that means that if this is a speed of a car as a function of time and this is your time variable, then you can see that there is a possibility that first the speed was decreasing and then again it started increasing and it got the same speed at two different times. Yes, that is a possibility and that is okay with functions. Obviously, this kind of function is not a one-to-one function because it is repeating itself, though it is a function. But when you do inverses of these kind of functions, what you're doing is that you're interchanging domain and range. So if you want to put the variable on y-axis on the x-axis and the variable on the x-axis on the y-axis, then such a function would transform something like this, which will not remain to be a function anymore. So that means not all functions have inverse functions. Only those functions which are one-to-one functions, which are not repeating themselves, only such functions can have inverses. So if a function repeats itself, yes, it is a function, but such a function will not have an inverse function. So in some cases, you will see that it is always going to be an increasing or decreasing function. As you can see over here, this is an ever increasing function. So it's not repeating itself. So it is a one-to-one function and it can have an inverse. Or you look at this example. This is a decreasing function for this interval and then again a decreasing function for this interval. So it does not repeat itself at any point. And how can you check that? You can make some horizontal lines and you see if it cuts at two different points. It is not cutting anywhere at two different points. So this is an example of a one-to-one function. And such functions will have an inverse. But if there is a function that decreases and then increases for a same interval of ranges, then you will see that it is basically repeating itself. So that means if you put one value of range, you will get two corresponding domains. It still is a function, but it is not a one-to-one function because it is repeating itself. So such functions will not have inverses existing. If there is a function like this, which is not a one-to-one function, you will be able to say that this function does not have an inverse. You can take another example over here. The function is increasing and then decreasing again, and you can again see it's repeating itself. So yeah, this is a function, but this does not have an inverse function. Now, once you have identified that the function has an inverse, it's a three-step process to find out the inverse function. So for the equation given, in place of fx, you will write y. And then you will rearrange the equation making x the subject. So you write x in terms of y. So you make x the subject of the equation. And then after you have made x the subject of the equation, in place of x, you would write f inverse x, and in place of y, you would write x. And that is where you have found out the inverse function. Keeping in mind that you can only find inverse functions of one-to-one functions. So have a look at some of the examples. Like these equations are given to me and I have to identify if these functions have inverses or not. So if you will look at this particular function, the first one, it's an increasing function always, it's a one-to-one function, yes, it has an inverse. If you look at second example, it decreases and then it increases again, and we can identify that the function is repeating, which means that it is not a one-to-one function, and hence it will not have an inverse. This is also an always increasing function, and yes, it will have an inverse. This is also an always decreasing function, and yes, it will have an inverse. But if you see this function, which is increasing and then decreasing, so it has values of ranges repeating, which means this function will not have an inverse. Now moving on, and look at some examples where we have to find out the inverse functions. So if you are being given this function and you have to find inverse function, first thing is that you, in all of these functions, if you know they are one-to-one functions, then you replace fx by y, then you make algebraic rearrangement to make x the subject. So I shift 4 on that side and 3 on that side, so it becomes y minus 4 upon 3. And after finding out x in terms of y, the last step I have to do is replace x by f inverse x and replace y by x, and I have found myself the inverse function. So I'm going to do the same thing in all these different situations. Sometimes it might be a little tedious algebra, but my goal, my target should remain same. I have again rearranged this equation, made x the subject, and found the inverse function. So I'm doing the same thing in all of these different examples. So that's how you basically find out the inverse functions. Now, since we have already identified that if a function repeats itself, then it will not have an inverse. But if we restrict the domain of many-to-one function in such a way that it doesn't repeat itself, we don't allow it to repeat itself, then that will have an inverse. Like if you look at this equation, this is a quadratic curve, it forms a parabola with a turning point 1 and 5, and we can see it's coming down and then going up. So it is repeating itself, and definitely it doesn't have an inverse. But if I take a section of this graph, maybe a section that is this point onwards, or I take a section of this graph that is this point onwards or this point onwards, then all of this is not going to be repeating itself. So I have actually sort of discarded that portion of the graph where it was repeating. So if I only take that part of the graph where it does not repeat itself, then it will be a one-to-one function, and then it will have an inverse. So here the question says, x is greater than or equal to k, and find the least value of k for which f has an inverse. So if I take greater than or equal to 4, then it will be a one-to-one function and it will repeat itself. If I take greater than or equal to 3, then again it will be a one-to-one function, it will not repeat itself. If I take greater than or equal to 2, it will still be a one-to-one function and it will not repeat itself. But if I go beyond 1, like if I take it from 0 onwards, and you know, it's for some part it goes down and then it goes up again. So that means it repeats itself and it doesn't stay to be a one-to-one function, and hence it will not have an inverse. So the least value of x I can take can be 1, nothing below that. So the least value of x would be 1, and hence k would be 1. And once I've identified that value, then I can also find out the inverse. The same way, I will replace fx by y, I will make x the subject, but there is one more thing that you must remember. When you find a square root, you know that the square root means that you have to introduce a plus and a minus sign. But since it says x is greater than or equal to k, which can also be stated alternately as x is greater than or equal to 1, or x minus 1 is greater than or equal to 0. So you know that x minus 1 has to be positive. So when you get this root sign and you know that there is an option of a plus and minus, for this particular condition, you have to take a plus sign. And then you move on, make still x the subject, and find out the inverse function. In the other example, it says x is less than or equal to n. I find out the turning point, and the turning point comes out to be negative half and 7. So once by equating this to 0, I'll get the x coordinate of the turning point, which is going to be negative half, and the y coordinate is going to be 7. So once I've found out the turning point, and I know that its coordinates are minus half and 7, so I know that minus half is where it turns. So I have to take x is less than equal to n. So I can take less than equal to this value. Like, I mean, if I pick something like, let's say, minus 2, and I take less than equal to minus 2, then it will be just that part of the curve which is towards the left. And that means it will be a one-to-one function. So I can take n up to minus half, but not beyond minus half. For instance, if I take n as 0, then that means I'm considering this part where it repeats itself. So the maximum value of n I can take is again this turning point, which is going to be minus half. So I can find out that n in this case is going to be negative half. Not just that, when I'm rearranging to find out the inverse function, and when I take a square root, and after finding out the square root, I know I have a choice of picking plus and minus. But since x is less than equal to n, and n is negative half, which means x is less than equal to negative half, or 2x plus 1 is less than equal to 0, means that this thing is negative. And if this thing is negative, so that means I'm just going to pick the negative sign and discard the positive sign. So it's not always going to be positive or always going to be negative. So you have to look carefully and identify what the sign you have to take. And once you pick that sign, obviously from that point onwards, it's a straightforward working. You may still continue to make x the subject, and then finally you replace x by the inverse function, which is in this case g inverse x, and you replace y by x always. So for this function, the turning point is minus 1 and 2, and hence x has to be greater than equal to minus 1. So the least value of k has to be minus 1, and once I've found out the least value of k, I can find out the inverse function. And since it's greater than equal to minus 1, I'll have to pick the positive sign. Likewise, over here, x has to be less than equal to n, so I can take the turning point, which is going to be half, and if I take the turning point as half, so I know that it's going to be less than equal to half, which means that 2x minus 1 has to be negative. So out of this plus and a minus sign, I picked the negative sign, and then I've made the inverse function formula. Another example where I have fx is equal to 1 over x squared and x is greater than n. So you can see that it goes up and then it comes back down. So if I have to take greater than equal to n, then the least value of n I can take is 0, because if I go beyond 0 and I take greater than that value, then it goes up and then it comes back down and it repeats itself, and it does not stay to be a one-to-one function. So I will know that the least value of n is going to be 0, and then after doing that, I can find myself the inverse function. Again, when I took the square root, I had a choice of plus and a minus, but because of this greater than sign, I'm just going to pick the positive sign and find the inverse function. The same idea could also be applied to trigonometric functions. So you can see if it's a sine function, it's a cyclic repetitive function, it just keeps on repeating itself, but it says what is the largest value you can take, so that it is a one-to-one function and it has an inverse, so you know that you can go maximum to pi by 2 from 0, because if you go beyond pi by 2, it will repeat itself and it will not stay to be a one-to-one function. Once you do that, I mean, you can, in one step, you can easily write down the inverse function. The notation of inverse of sine is sine inverse, of inverse of cos is cos inverse, and inverse of tan is tan inverse, of course. Another example, if you have a function which is cos 2x and you will sketch the graph, you will see that it starts from a maximum value, and then because it's cos 2x, then it turns at pi by 2. So it keeps on decreasing, and then after pi by 2, it increases. So pi by 2 is that value where it starts repeating itself. So the largest value of n that I can take is going to be pi by 2. And after taking that value of n, I can just simply find out the inverse function by following the basic step. One more thing I would want you to know is that not in all cases you have to find the inverse function. Like if a question says that fx is x plus 1 over x and you have to find f inverse 4, then don't do that long process of finding out the inverse function and then putting x as 4. Or you can just use the concept that 4 is the domain of inverse function. So for original function, it would be a range, because by finding inverse, we're just switching domain and range. So without finding the inverse function, I can directly put 4 as the range of the function, save myself with quite a bit of algebra, and solve it to get the value of x. But I also know that x has to be greater than or equal to 1. So out of these two options, I'm going to pick that value of x which is greater than 1. Thank you so much, guys. I hope this helped, and if it did help, kindly do subscribe to the channel and give a thumbs up.